Hello everyone. In this video, we are going to talk about Chapter 12, Section 12.9. Today we are going to learn about dependent motion. There are tons of applications to it. One of my favorite is this one. If you want to move a piece of furniture upward, right, using the pulley. So as this truck goes to the right, the furniture is going to go up. Being elevated to the first floor, second floor, third floor, if however needed. So let's say we have two blocks on two different sides of this inclined plane. Block A is gonna go up and down on the left side of the inclined plane. Block B is gonna go up and down on the right side of the inclined plane. When the A go up, B is going to go down. When the A go down on the left, B is going to go up on the right. Their motion is going to be dependent on each other. Now, what's not changing is the total length of this cable that's connecting block A and block B. The total length, when I said the total length, there is this cable. Let me highlight it. What's a good color? Let's choose green. This cable overall from here to here. Let me try it again. Going from here to here. The cable, total length of this cable does not change. Total length of the cable is a constant. With that being said, we can write down our equation as A, distance as A, which this term right here is not a constant. This thing changes depend on the location of A. And also SB is the same thing. SA and SB is not a constant. These two terms changes. The length CD, the arc length CD, it's going to be a constant. The red portion, I highlighted green, but originally highlight in the graph is a red. It is a red portion of the cable. LCD is a constant. Also, LT, the total length of this cable is a constant. Okay, but overall, SA plus LCD plus SB equals LT total. Now, if I'm going to take the first derivative of this equation that we just wrote together in this slide, this equation right here, if I want to take the first derivative with respect to time, notice that SA, the length, the SB, the total length, is all going to be the position, okay, the distance, right? It's a length, quantity, physical quantitative length. When I take the first derivative with respect to time, I get velocity. So in other words, I get velocity. Let me keep writing here. Derivative of SA will give me velocity VA. Okay, since LCD is going to be a constant, that means I take the derivative of a constant, I get a zero, and I keep going. Derivative of SB is going to be velocity of the block B. And then total length is a constant, that gives me a zero. Based on this equation, I can conclude that VA equals negative VB. Okay, they are equal on the magnitude, but opposite on the direction. And notice that when I say opposite on the direction, they're not truly opposite because they are at an angle. Okay, but you know what I mean. Okay, so this is what's going on this slide, which is what I just explained. I am taking the derivative of the that equation right there. SA plus LCD plus SB equals LT. I get velocity VA equals negative VB. And if I'm taking the derivative of this equation again, I get the acceleration. It means that acceleration to B, AB equals negative AA. Okay, so this means negative sign indicates that A moves down the inclined plane, positive SA direction, when B moves up in the inclined plane, negative SB direction. All right, next one. Again, I have this pulley system. If you notice that when the A, similar to that truck that moving the furniture, similarly, I have this block A moving to the right. That block B, if A is going this way, that block B is going to go up. If I'm going opposite, A goes to the left, that B is going to go down. Okay, so block A and block B, dependent on each other. We do know that since they're connecting by one cable, they are connecting by one cable. The total length of this cable is a constant. That's right, our equation. Since the total length is a constant, right, we're going to ignore the red part. We're going to ignore all the red part because they are going to be constant, no change, right? We know that SB, this portion is SB, and I have two of them, SB number one, SB number two. Two SB together, and then plus the H, which is the height from there to there, okay? Plus the H and plus SA, which is this portion right here, plus SA, equals the total length of the cable. And I know it's not the truly total length of the cable, but we're skipping all the red parts because we know those portion does not change. Now, taking this equation, I am going to take the first derivative. Taking the first derivative with respect to time, I know this part is going to be a zero. This part is going to be a zero as well when I'm taking the derivative with respect to time because h and the total length of the cable does not change. So in conclusion, okay, when I take the first derivative, I got 2b equals negative VA. And I'm taking the derivative of that velocity equation again. I got 2AB acceleration AB equals negative AA. Okay, when the B moves down, positive SA, block A moves to the left, negative SA. And remember, be consistent with your sign convection to the left, to the right, which one's positive, which one's negative. This slide right here shows you that, well, depends on where you take as your datum. Where do you take as your reference point? You may could also write your equation a little differently. This slide shows you that you can use the bottom instead of the top. You can use your bottom as your reference point. If I'm using the bottom as my reference point, essentially it's the same thing, but we are writing this equation slightly different. So 2 times h minus sb. So if I set SB as from here to the datum, the bottom instead of the top, okay. On the previous slide, on the previous slide, we defined over here as your SB, right? Now SB is down here at the bottom, but still, when I'm writing my equation, it's two of this green portion. How do I get that green portion? That green portion is going to be the H minus the B. H minus B, and I have two of them. Okay, so it's 2 parentheses H minus SB, and then plus the H plus another SA equals LB. And then I'm taking the derivative with respect to time. First derivative gives me the velocity equation. Second derivative gives me the acceleration equation. But either way, however you choose your reference point, however you prefer, we will get the same equation. Now, general procedure, general steps to write the dependent, whenever you see problems like this, dependent motion, we're first going to define positive coordinate from fixed reference line, fixed datum line, along the path of each particle. We're going to define the datum line can be used for different lines could be used for different particle. So there may be different ways writing our equation, the relationship, just as we discussed from the previous two slides. Next thing, step number 2, we're going to relate the positive coordinate to the chord length. Segment of the chords that do not change in length during the motion may be left out. And number 3, if a system contains more than one chord, we will see in an example like this, okay, more than one chord, you're going to relate the position of a point of one chord to a point of another. Separate equations are written for each chord. So in other words, the total length of each chord is going to be a constant. Under the condition that you see more than one chord, you're going to write more than one equation. You write one equation for each chord. Step number 4 says differentiate the position coordinate equations to relate the velocity and acceleration. So in other words, once you get your equation for the chord, for each chord, first derivative gives you the relationship of your velocities. Second derivative gives you the relationship for the accelerations. Okay. In the example, so I have this pulley system. I am pulling from the side A going down. That means this block B is going to go up as the A pulls down. We know that A pulls down with the velocity of 3 meters per second. We will find the speed of block B. When we set our datum reference point to be at the top, where the B and the C is at the top. Okay, so Based on here, you have three SD. Look, SD number 1, SD number 2, SD number 3. 3 SD plus SA. SA and SD, they are going to change, but they are dependent on each other. SA plus 3 SD gives me the total length of this cable. First derivative, I'm taking the first derivative, gives me my velocity. VA plus 3VD equals 0. So I'm taking the first derivative. Since the L total length is going to be a constant, that means first derivative gives me a 0. There gives my equation. How am I relating the VA to VD? Now, since VA is given to us in our problem, we're looking for VD. We know our relationship between VA and VD. Plug in one of them, that will give us the value of VD. Next example, this problem, look, we got two cables. That means we are going to write two equations. Cable number 1, cable number 2. We are going to write two equations. Okay, we know the velocity of A on the left side of the drawing, on the diagram. A is going down with a speed of 2 meters per second. We're looking for the speed of block B. Now, over here, we're going to set the top as our reference point, top as our datum, and then we write our first equation. First equation is going to say SA, which is a changing variable. It changes, depends on where am I pulling on this left end of the pulley. Right, left end of the cable. So SA plus 2 SC number 1, SC number 2. SA plus 2 SC equals the total length L1. And then chord number 2, says you have your SB, which going from here to here. There's my SB plus this portion. Okay, let me use a different color actually for the second equation. Let me get rid of that. I may use purple. It's a little more noticeable. SB, it's this portion I need for the second chord. I need this portion plus this portion. Okay, that means the purple one, the first portion is going to be your SB right there. And then the second portion is going to be SB minus SB minus SC. Okay, so these together gives me L2. Putting these two equations together, if you wonder, ooh, how do you put that together? We have two equations and solving for two unknowns. What you're going to do, see, look here, you have a first equation, you have a positive 2s. That means on my second equation, I'm going to generate a negative 2s so that I can combine them together. Okay, so what I'm going to do is multiply by 2 throughout the entire equation, multiply by 2. And the reason I do that, so that when I do addition on these two equations, top minus bottom, the SC 2SC cancel out. There's a positive 2SC, negative 2SC. I do top minus bottom, adding these two equations together. I end up with SA. Look, 1SA, there's my 1SA, and then 2SB plus another 2SB. That gives me 4SB. Right hand side will be L plus 2L2, L plus 2S2. Okay, now taking the derivative of this equation with respect to time, that gives me the relationship of VA and VB, a relationship between the two velocity, VA and VB. And then we are going to plug in the value of A, which is given to us 2 meters per second. We plug in the value of VA, that will give me the value of VB. Okay. Last problem right here. This one's actually only one cable. That means I only need to write one equation. Okay, we know the block C is moving downward. Block C is moving downward at 18 feet per second. So that's write our equation to relate the ABC together, position and velocity. So we have the top as our reference point. I have SA plus 2SB, SB number 1, SB number 2, 2SB plus 2SC, SC number 1, SC number 2. Okay, so I have SA plus 2SB plus 2SC equals a constant. Taking the first derivative, since L total is a constant, that means I'm taking the first derivative, VA plus 2VB plus 2VC equals 0, taking the first derivative. And then your VA is going to be 6. Hold on. Why is VA 6? Your VA is going to be 6 plus 2 VB plus 2 times 18. The 18 is given to us in the problem. Oh, right here. Sorry, I misread that. 6 feet per second for your block A. Block A is 6 feet per second, and then block C is 18 feet per second. Okay, so we know VA and your VC, plug that in. That will help us calculate the value of VB, which is negative 21 feet per second. And a negative sign means that I am going up because we define as going down, positive. Okay, so this is all I want to share you in this section, dependent motion. Hope you find this video helpful.